Hello, my name is Wei Chen Eric Wong. I am currently a PhD student at MIT ECS. This is a joint work with Jonas Muller. Jonas is the chief scientist and co-founder of CleanLab. We're very excited to present our work at the Internal P workshop in Europe's 2022. In a typical machine learning setting, labels are always assumed to be correct, but it turns out that it is not always the case. CleanLab discovered that label errors are indeed very prevalent in many datasets, even for some of the very popular datasets. These kind of label issues can range from 0.15% in MNIST up to over 10% in quick draw. And these kind of label issues can span across visual, text, and audio datasets. CleanLab has been working on label error detection. In their recent finding, they showed that their algorithm is able to detect label errors in out-of-distribution samples, which means that the sample does not belong to any of the desired set of classes. In our work, we focus on token classification. So in this example, Wednesday is given an organization entity, but it's supposed to be a miscellaneous entity. The idea here is to assign a label quality score for a multi-class classification task. Here we let X denote the given labels of n samples. Xi will be the given label of the ith sample, and it will be between 0 to k minus 1, where k is the number of classes. We use a pre-trained model or using cross-validation to get a set of model predicted probability. And here, cross-validation means that we split the sample into, for example, 10 folds. We train a model based on the 9 folds, and then get the model predicted probability on the remaining fold. And then we repeat this to get the model predicted probability for each data point in the given data set. P here is the matrix of n by k, where Pij is the probability of the I data belonging to the J class. So here, each row of P, which is Pi, will sum up to 1. CleanLab proposed three methods to assign a score to each label. So first one is self-confidence. It's simply that Qi is Pik, and then K is the given label. Qi is Pik normalized by the probability of the model prediction. And the confidence weighted entropy also considers the entropy of the distribution of the model prediction. Here we focus on name entity recognition task. So it's a task of locating and classifying name entities from text. In this example, we have person, location, and organization, 3 different name entities. And we use O to, we reserve O to indicate an unnamed entity. Consider this sentence: Michael Jordan plays for Chicago Bulls. A correct model will tag Michael and Jordan to be person, Chicago and Bulls to be organization. To verify that whether a token is really mislabeled, a reviewer must read the entire sentence to understand a broader context. Using the previous example, if we're given the word Chicago, the intuition would be Chicago will be a location. But if you're given the entire sentence, it becomes clear that Chicago is referring to a part of Chicago Bulls, which is an organization. So here the idea is to assign 1 score for each sentence so that we aggregate the quality score on the token level. We propose a simple yet effective algorithm which we call it the worst token. It is the quality of the worst labeled token in the sentence and that will be the score that determines the overall sentence quality score. The QI here will be the token quality score of the I token using one of the label quality scoring methods as described above. We believe that this is the most reasonable way to rank sentence that contains at least one label error. Here we consider the Colonel 2003 dataset. It's one of the most widely used name entity recognition dataset for benchmarking and then for NLP research. It contains 4 name entities: location, person, organization, and miscellaneous entities. Again, O here is used to reserve unnamed entities. For the named entities, which are location, person, organization, and miscellaneous, we have B and the I prefixes to indicate whether the word is in the beginning or the intermediate of the text chunk. In this example, Japan is given the entity B-loc, which indicates the beginning of the location. Here, China is given the B-per, which is the beginning of the person entity in the original data set, which is an obvious label error because it should also be B-loc, which is the beginning of the location entity. Colonial++ is another data set where they manually verify and correct the test data set of the original Colonial 2003 data set. And after an extensive review, we believe that all of the label errors have been corrected, which we will be using Colonial++ as our ground-truth data set. A bit more than 5% of the sentences contain at least one token label issue. It here represent distribution of the mislabels between the 2 data sets. And here we present the workflow of our experiments. First, we obtain 2 sets of model predicted probability using the 2 pre-trained models. The second step, we consider more severe label errors. For example, we consider location versus person instead of the beginning of a location entity versus the intermediate of a location entity. And we do it by omitting the B and I prefixes. So we have 3 different experiments. The BIRD and the XLM uses the 2 sets of model predicted probability, but we omit the B and I prefixes. The BIRD unmerged uses the third BIRD-based model, but we do not omit the B and I prefixes, so we consider the full set of entities. And then we evaluate each combination of sentence and token scoring method based on 3 criteria. The first one is lift at the number of errors. So this calculates how many times more prevalent label errors are within the top T scoring sentences versus the entire data set. Here, T is the number of label issues. The second and the third criteria are AUROC and AUPRC, which are really common in information retrieval literature. So here we use sentences that contain at least one label error to be a true positive. And then we calculate the area between the received operating characteristic curve and the precision recall curve. Here we present the results of the AUPRC using different sentence scoring method and token scoring method. We show that the worst token consistently outperformed other sentence scoring methods when we use self-confidence as the token scoring method. And to learn more about the other sentence scoring methods, they are presented in the appendix of this presentation. And of course, they are also a part of our paper. So using worst token in combination with self-confidence, Here we list the top 10 sentences, which are the 10 sentences with the lowest sentence score. Note that miscellaneous and other entities, miscellaneous versus other entities are excluded because they can sometimes be a bit arbitrary and hard to differentiate. Note that 7 of the 10 sentences circled in red contain actual label issues, and we're able to use the model predicted probability to assign a correct label to the mislabel. For more details, please check out our paper and our code implementation. And to learn more about CleanLab, they frequently post their recent work on their website. Lastly, if you have any question or feedback, please feel free to reach out to me or Jonas. We hope you enjoy our work, and thank you for your time.